Hello students, we are solving a question from rotation. This is from 24th January shift 1, JEE Mains 2026. The question says two masses 400 grams and 350 grams are suspended from the ends of a light string passing over a heavy pulley of radius 2 cm. When released from rest, the heavier mass observed to fall 81 cm in 9 seconds. We are to find the rotational inertia of the pulley in kg meter square. They are given g as 9.8 meter per second square. So what we shall do is, first of all, we will assume there is no slipping in the pulley, because that is what happens when the pulley has rotational inertia. The whole point of giving rotational inertia is that the difference in tension is created which rotates the pulley, and for that friction is also required. So we'll assume that the pulley does not slip at point P with the rope. So at point P, the acceleration of the rope A and the acceleration of the pulley, which is r alpha, must be equal. This will give us A equal to r alpha. Next, if we apply laws of motion on the m2 mass, which is pulling the system down, it will be m2g minus t2 is equal to m2a. Similarly, we can apply laws of motion in y direction on the m1 mass. This will give us t1 minus m1g is equal to m1a. Sorry, I think I have taken the tensions in a wrong manner. So I shall align the tensions. This one we will take it as T2 and this one we will take it as T1. So M2G minus T2 is equal to M2A and T1 minus M1G will be equal to M1A. Next, we shall apply Newton's law of rotation on the pulley. So the rotating torque are T1R minus T2R. I think here also we need to kind of change the order. So here T2R is actually rotating it clockwise and T1R is rotating it anti-clockwise. So T2 minus T1 is equal to I by R square into A. This is my third equation. Now what we can do is we can simply add these equations. Your minus T2, which will get cancelled out with the plus T2 here. And here you have a plus T1 which will cancel out with the minus T1 on the LHS in equation 3. And if I add all the three equations, M2G minus M1G is the only term remaining on LHS, whereas on RHS you will have M1A plus M2A plus I by R square into A. So here I have substituted alpha as A by R, that's why I am getting I by R square into A in the RHS, right? So if I take A common, it will become M1 plus M2 plus I by R square into A. So acceleration will come out to be m2 minus m1 into g divided by m2 plus m1 plus I by r square. In fact, if you ever get a pulley plus two mass system, you can just remember these expressions, right? And acceleration is a constant. So bodies are moving with constant acceleration. They said that the heavier mass descends 81 centimeter in 9 seconds. So using s is equal to half a t square, because the body is starting from rest, you'll get this acceleration to be equal to 1 by 50. Now, g into m2 minus m1 divided by m1 plus m2 plus I by r square is 1 by 50. So if we calculate, if I put g as 10, although they're told to take g as 9.8, I'll take it as 10 for simplicity of calculation. You'll get the moment of inertia to be around 9.7 into 10 power minus 3 kg meter square. Now the closest answer to this is option 4, and you will get exactly option 4 if you take g as 9.8. But for calculation simplicity, I have taken g as 10.